while I do these announcements? That's gonna be lit.
Oh, okay, yeah.
Max, do you want to come up later?
Yeah, am I gonna sit
This mic?
Yeah.
Hello.
It's so quiet.
It is. All right. What's up, everybody? Welcome to RITSec. This is the last official meeting of, I guess, the spring. We have, yeah, it is kind of sad. We have events, ShmooCon, and then elections. After that, we'll post the whole schedule. But yeah, let's just get rolling, I guess, as I click things. If you haven't already, please sign in to RITSec. Sign in to RITSec.club. Elections are coming up, and you need to have signed in 3 times. That can be interest groups or any other RITSec events. You need to have 3 sign-ins to be able to vote. So please, please, please sign in. We need to keep track of this stuff. All right, let's go over some quick announcements. Classic, join the Discord. I don't think I need to say most of this stuff at this point. Calendar, in the coming weeks, we're going to post everything related to elections. So check out the calendar. The mailing list, if you want to know what we're doing every single week, join the mailing list. Feedback. If you have any feedback for us, whether that be positive or negative, it's anonymous. For e-board, something we do, anything, please fill out that form and sort of help us out there. Max, you want to hop up for this? Okay, so just to give you guys, if you didn't see the post and announcements, we're doing a sort of major revision of the Constitution. Max is going to talk about most of the changes. Well, yeah, go for it.
Yeah, so first to start off, again, if you haven't seen it, in announcements, we add member for it. Also, to notable, there's going to be a 1-week review on this, and it's going to need 2/3.
3/4.
3/4?
Yep.
3/4 for a veto if anyone, or if you guys are against it. And it's completely open for discussion. Feel free to ping me, Enzo, or anyone on eBoard. I would probably suggest us two because we are some of the main contributors to it. And then I kind of want to talk about why we're making this change before we talk about the specific changes itself. So, when we first established the Constitution for RITSec itself, we put in the Constitution said that we wanted to have an update every single 5 years. It's been 4 years. We're about to go on number 5. We figured it's probably about time. We're seeing just enormous growth in the club, and we need scalability. And we hope to cover that with this constitutional edit, as well as some stuff like the social media head has never been formally put into the Constitution, and it's been 2 years of having a social media head. So there's certain stuff that just needs updated. And finally, with that idea of club growth, we've seen the president take up all those extra responsibilities of all the new stuff that we have to do. So we're looking at expanding the idea of president into also having a vice president so that they may be a retainer. So going onto those specific changes, like we said, the addition of the VP, having that second person on retainer so that the club may function properly and not completely overbear a single person, being the president. Next, also to be noted, that would be elected this cycle. So with nominations, assuming all this goes through, we would be electing a vice president. We also formally added the social media head. So Claire will finally be in the Constitution. That's a possible veto if you do not want that. And overall, just a grammatical and organizational overhaul. There's like small stuff like commas and just a bunch of stuff that needed to be in the Constitution that wasn't. Like even until the current Constitution doesn't make a formal declaration to the difference between an IRCA and ISTSCA. And so we just rewrote and trying to make roles a little bit more specific and overall just get everything up to spec. Mm-hmm. And again, feel free to ask either of us. Ask us anything you want, anything you see. we're open to the discussion, and the vote for this should be next week.
If someone brings something up, you have
Yeah.
1 week available to make changes and
Yeah.
talk to us. So, or propose a veto.
Mm-hmm.
Okay, cool. Discord or in person, either one. Yeah. So.
Oh, cool.
Yeah, we do that.
Okay.
So thanks, Max.
Sounds good.
All right, so round of applause for our sponsors, please. We could not do it without them. We appreciate them very much so. And of course, follow us on social media now that Claire will be in the Constitution. Okay, without further ado, physical security with Loudon.
What's up, guys?
Yes, please clap for Loudon so you can click on these here.
Yeah.
Since it's all kind of messed up, so just click on that. You can kind of read from it.
Is this thing on? Alright, I'm going to proceed to not use it at all. So, this is for you guys who couldn't make it to physical security. Maybe you had like a class or you just didn't want to go. So, you'll be subject to this now because we ran out of things to present on, and this is the education, the last one. So, a little bit about myself. This is my intro slide. I am a 4th year now, and I run the Physical Security Interest Group. What's up, dude? I founded it, that would have been my freshman year. I'm the vice president of the beekeeping club. Fun fact, we have bees on campus. Dude, hit me up if you want to talk about bees. They're pretty cool. And then those are my cars there. I work on them. Check them out. I like cars, guys. Now, you may be wondering, it's probably been a little while since you've seen an ethics disclaimer here at the RITSEC Club. Now, there were supposed to be ethics disclaimers just kind of like every week, but I figured I would just kind of throw this in here as a little redundancy. Just for any of you familiar with the RITSEC Physical Security Interest Group, Mondays from 1 to 2 in Golisano, 1710, 1720, and 1730, you will know that we have an extensive ethics policy that prohibits you from using any of the knowledge that I will bestow upon you for malicious means. Now, that was basically what this slide was put in here for. Just anything that I show you here, please don't be, malicious with said information, because that would reflect poorly on me and my judgment for teaching you all of these crazy things. Here's my overview. The idea of this presentation is to just kind of run through a general attack kind of layout of things that one could do given a situation that are not necessarily related to locks, and then there's some more lock-centric stuff near the end of the presentation here. Starting off, I don't know how many of you guys are familiar with this trick. I'm going to assume most of you, but for those of you who are unaware, some doors will be set up in certain facilities with an exit unlock sensor device thing here. They usually look like that, motion detector sensor, and this is so that you do not have to unlock the door on your way out. It will just sense the motion, unlock the door, and you can proceed as you want. Now, say you're an attacker, you can trigger this motion detector using, commonly it will be a can of computer duster, and that's for 2 reasons. I have to stand in front of the stream.
Can't hear you on the microphone.
I didn't know it was a mic thing. I figured it was probably they could just not see me. Fine, I'll stand right here. Alright, just be prepared. My fidgeting is going to be worse. So the reason for this is twofold. Some of these sensors actually detect a change in temperature and a change in motion to open the door. So using this computer duster, if you turn it upside down, it will send out a stream of like this really cold air that will trigger the heat sensitive ones as well. Now, a less technical way of doing this, or a less involved way, is if there's a big enough gap, and this is assuming that you can get this around like a gap in the door to trigger the sensor. Sometimes it'll be installed so carelessly that there'll just be like this huge gap between the doors and the sensor will be like right in the center. So you could just stick like whatever random trash you can find through there and it'll open. This actually happened on co-op for me over the summer. We did an in-person like assessment at a company in Pittsburgh who shall remain nameless, and their like lobby doors were set up this way, and we were coming back from lunch and I was like, you know what, I could probably just stick this bag between here and open the doors. Fucking worked. So just making sure you understand all of the different approaches and have all these different ideas in your head. Don't like get locked into the idea that you must pick the lock. Like there's a lot of other approaches here, and that's kind of the idea of this presentation. Now another one of these would be hinges. Now this can seem fairly innocuous, but if you have access to the hinges on a door, like if they're facing outwards, you can just like pop the pin out of the hinge. You kind of take it apart and then you can pull it off, and it'll stop like holding the door there, and you can take it off. There are special hinges that they make that don't make this like possible, but you're gonna be hard pressed to find them installed anywhere. I don't think I've ever seen them here, but they have like a pin that'll protrude from one side and go into the other, so when it's kind of sandwiched together as it would be when the door is shut, you cannot move the door without kind of opening it from the other side first. Hinges are a fun one. Door latch mechanism. This is super common. So, and I'll get into why it might be common here on campus as well. But first, I have to set up the actual kind of idea of this mechanism here, right? So, as you can see in the center, that's the latch of like a pretty common door latch. I'd imagine you've seen one of those sticking out of the side of a door at some point, right? Now, really important to this mechanism is that when you shut the door, that whole part that's protruding from the plate there, the latch, is going to be depressed by the door frame in order for it to close, and then it kind of pops back out once the door is closed into this thing here, which is called a strike plate. I don't know if anyone here is watching on stream, but it's the one labeled strike. I just pointed at it. That one there will interface with the latch and kind of hold it there. Now, where this gets tricky is originally they were very simple. It was just like a spring-loaded mechanism, and the door handle would kind of retract it. However, that's vulnerable to kind of slipping the latch. Like what you would do is you stick some sort of piece of metal in there, and you can push that latch back without actually interacting with the doorknob, and then you can open the door. So door latch designers added this thing here. I think it's sort of labeled on the picture. I was just going to point at it. But if you see the latch, there's two distinct like pieces that are sticking out past the plate there. One of which being the kind of like the actual latch. It's shaped like a wedge. And then the other one being that sort of like semicircle cylinder thing on the back. That is called the deadlock plunger. And that's very important to installing doors properly. The strike plate has to be a very particular size in order to accommodate only the latch portion and not the deadlock plunger. Meaning that when the door is fully closed, the deadlock plunger should be in a depressed position. And this, because of some sort of mechanism inside of the latch, means that from there you can only open the door with the handle. You can't actually get anything between there and like slip it open like you would be if there was no dead latch plunger. So where this gets tricky, or I guess forgotten more so, is with these here. These are electric strike plates. You can find these installed in just about every commercial application ever. It's used for, when you swipe in. This is the thing that actually makes the clicking noise and allows you to open the door. There's like some sort of magnet in there that pulls something out of the way, and then you can open the door. Now, it's very common for contractors to just stock the largest size of these, because there are different sizes of latches, and they'll just always have the largest one because it'll fit on all of the latches. Now, unfortunately, that causes some problems with the deadlock plunger that I mentioned before, because the strike plate needs to be a very specific size in order to ensure that pin is depressed. So when you go to a system like this and you don't actually make sure that it's the right size, you're opening yourself up to attacks where someone could, I don't know, say slip a credit card or something between the door frame and open the door. Or should it be installed facing the other way in the door frame? There's a metal tool that they make that I think I have on the next slide here. Yeah, so these are some tools for slipping latches. As you can see on the left, those are those metal tools that I was referring to. That's if the kind of sloped portion is facing away from you. You can kind of reach around and pull backwards, and it'll slip the latch for you that way. Or if it's facing you, you can use, these are some fancy ones here on the photo with the black background that I didn't edit out or anything. It's you can buy those. They're pretty inexpensive. Generally worth it. They're like more durable than say the alternative here. Garbage from the trash. You can just pick up random pieces of plastic, start shoving them in doors, and sometimes they might open for you, which is generally a bad sign. At least somewhere that cares about all of their students being safe or whatever, or things not being stolen. So here's another one. These are, I think they're called panic bars or crash bars. You've probably seen them before. They come in like different styles. You can see over there on the left, that's kind of like a hinged style, and then this one is like every door in every school all over across America ever. So these ones are, I think they're required by fire code that you have them installed in some buildings. And if installed improperly, they can very easily be, manipulated from the outside. So you would just need to stick some sort of rigid, like metal bar through the gap between the doors, which the fix is to not have a gap between the doors. You can install like some sort of plate or a center pillar there in the actual door frame to prevent this. However, if they're just stuck together like this, then you can just kind of stick a piece of metal around in there that you specially bent to actually touch that bar there and open the door. And this is a lot more effective than you might think. There are crash bars everywhere. I think the GCI conference room has this problem with the crash bars. There's like a huge gap between the doors, and sometimes they're locked too. So like, why don't I just bend a piece of metal to get in? This one is kind of in conjunction with the last one. This is a thumb turn tool. Now, some of these previously mentioned places with huge gaps in their doors will have the crash bars and stuff, but the crash bars won't work after hours because you've got one of these bad boys installed. It is a deadbolt, and they can usually be installed like lower on the door, and you can use them to like lock up or something. Now, if there's still that huge gap though, you can use one of these tools, which you can kind of maneuver through. And the handle is in two pieces. I don't know if that's super visible, but the red piece and the black piece move separately. So you kind of go like this, and it would rotate that little end on there, and that would be usable to open one of these deadbolts via the thumb turn. Now we've got some more door stuff going on here. Say there's no crash bars on the other side of the door. You could, in theory, given a large enough space under the door, fit some sort of contraption up under the door to, pull down on the handle and then open the door from the outside. This one also very effective, very common. Keep an eye out for that. I think the fix for that is maybe, not so much of a gap under the door. It's usually going to require a bit of a gap there. A little bit of a more kind of advanced attack here. We have some badge cloning stuff. You can buy these RFID like clone things on Alibaba for like 5 cents, and then use them to clone your various RFID tags and such. I have a picture up there of, that's a magnetic strip on a what would this be? Just a kind of a typical swipe card. They write out the magnetic strip, and it kind of correlates to binary, and there's all kinds of fun data in there that one could potentially clone given the proper reader and writing implements. This is one that may commonly get overlooked. A lot of keys may have already been compromised, and this might tie into a bit of your kind of OSINT beforehand on a given engagement. But if you can figure out that maybe an employee posted that they're so excited to start their job, take a look at my badge and keys, I'm posting this on Facebook. Something like that. There's also like TSA keys are very famously compromised with pretty much literally that. They just like took a picture of all of these keys and posted it, which these are supposed to be like key controlled. They're all, I don't know how familiar you are with the TSA locks, but you can see that there's locks that will have this little red like diamond on them. And that means that they have a lock on them that can be opened by TSA with their like universal keys, and they're all the same. So stuff like that. I mean, generally you're probably not going to be locking your stuff up with TSA locks unless it's, baggage, but definitely something to keep in mind. You have elevator fire escape keys. Those are very often mandated by local laws and such, and I believe in some cases the actual bidding code will be published in the legislation, so just compromised from the get-go there in case you wanted to use a fire service on an elevator. Continuing with the OSINT theme, you can find funny things in the garbage at a given location. I just kind of figured I'd include this, but a lot of sensitive documents don't make their way to the shredder or the recycle bin, and they can find their way into the normal garbage. So if you're really down, you could do this. I know Justin Pelletier, I mentioned this to him at one point, and he talked to me about how he loves digging through the trash and how he did that for the military or something. It's legit. Like, I mean, it might not be the most glamorous, but it is definitely an effective avenue for physical security engagements. Now, I think this is the last one before I start getting really technical about like lock stuff, but these are kind of like key boxes, I think. There's probably a better term, but what these are is you can put a key for like a door inside of this box and then lock it with either another key or like a combination here, as you see with the master lock one on the right. And essentially, what this will do is, if it's left like right in front of the actual door in question, usually the door in question will have a pretty secure lock on it, but these are like very bad. The one on the left has a tubular lock. You may recognize that from filing cabinets or computer locks or stuff like that. I'll get more into the different types of locks as we go forward, but just know that those are generally not very good. There's a $20 tool that you can buy on eBay that will open like 99% of those. And the one on the right here, that is a master lock product. You can kind of stick a feeler gauge between the dials, and that'll allow you to decode the actual combination for this pretty quickly, and then you can open that. And then you have a compromised key for wherever it was that you were trying to get into. Now, we're going to finally talk about locks. All of this not talking about locks has made me want to talk about locks. So here's all my locks. If you can see here, this is about kind of an outdated joke, but the actual kind of learning portion of this holds true. I just tried to make a kind of a hierarchy here of the various securities of types of locks that you may encounter. At the bottom, you have warded locks, and I believe I have slides that get more in depth into the specifications of these and how they work, but you got warded locks all the way at the bottom. Those are like the worst. They're universally opened by like a set of like 7 keys or something. You have wafer locks on the right here. Those ones are just very basic. They can be opened very easily. They're a lot like pin tumblers, but just cheaper. The center one there, what I already mentioned, the kind of computer power button looking thing, that is a tubular lock. Like I said, you can buy a tool that opens like a lot of them. The ubiquitous master lock number 3 is pictured there. That's just a lame pin tumbler, not super good. You got kind of residential deadbolt Schlage stuff there, which is the same kind of mechanism, but maybe a little more secure, maybe some security pins going on there. And I'll explain what that means, hopefully, going forward. And then you have SFIC in the center, which that is very common in commercial applications. You'll see a lot of locks kind of shaped like that here, with you have the core and then that kind of like, I don't know, forehead area on top. And then some more high security locks at the top that I will get to. I'm just going to kind of run through here a bit of a spotter's guide for the different types of locks that you may encounter going forward, and maybe you will take something away from this when you look at whatever lock it may be that you use to get into your apartment and such. Now, these are all conventional pin tumbler locks on this slide here. The center one being the master lock number 3 that I mentioned earlier. And then we have 3 different kind of form factors for more full size, like mounted indoor applications. You have, this is a kick cylinder here on the bottom right. That is that's a rim cylinder. Bottom left is kick cylinder. The rim cylinder is used for like residential deadbolts. It's super cheap. It's like very clearly a cast part, and then they just like put some holes in it and screw it on the door and call it good. They're generally pretty poorly machined, so like they'll be tough to pick, but like not for the reason you'd think, at least for beginners. Now, the one on the left, all that also holds true. That's a kick cylinder, which stands for key and knob. They will be mounted in doorknobs. And then top left there, that is a mortise cylinder. Those can be found more commonly today in commercial applications. They will be kind of screwed into the door, and then there's like a detent that holds them in. They were common on houses probably like, I don't know, 50 years ago or something like that. But now they're mostly limited to commercial use just because of how much metal is required for such a form factor of lock. It's a lot cheaper to just go with something like that. Now, I mentioned SFIC before. You've probably seen something that looks like this. This is a SFIC, or small format interchangeable core. I have a whole week that talks about this at the RITSEC Physical Security Interest Group, Mondays from 1 to 2 in Golisano, 1720, 1730, and also 1710. Now, this is the idea, the main principle behind this is that the lock will have two keys, one of which will operate the lock and the other of which will remove this kind of core assembly, allowing you to quickly rekey an entire institution. It fits into all these different like spaces. You can see there's a what is that, a mortise cylinder form factor. You got a padlock. There's kind of a Euro form factor for a door there. I'm not really sure what that one is, but that's SFIC. The actual nuts and bolts behind these are pretty neat. There's like 2 shear lines inside of the lock that make it work. Kind of resistant to picking. Now, tubular locks, I mentioned these like 3 times now. These are very common on filing cabinets and stuff like that. They work on the same principle as a pin tumbler lock in that they have like pins and springs and stuff, except they kind of work with a rotating face as opposed to a core which has holes drilled in it from the top. These, a lot of them that you'll find are very cheaply manufactured and can be defeated with those tools in the bottom left there. Those are the $20 on eBay tool sets. That's a self-impressioning kit. It will allow you to create a key by kind of inserting it and taking it out of the lock a number of times. And it works on like 90% of these, so generally not the most secure. Okay, next we have Dimple locks. I don't believe this was on my like tier list thing before, but these are a lot like pin tumbler locks. They're more common in Europe or maybe on like a bike lock or something, but the principle is the same. It's just kind of like the keyway is sideways, so the kind of recesses for the pins that are machined into the key are they're dimple shaped as opposed to kind of the traditional key shape you think of, where it's like kind of a sawtooth blade thingy that interfaces with the pins. And these are required that you have a specific kind of picking tool to get them open. Wafer locks, I mentioned these. These are very common in like filing cabinets again, and then like automotive applications, at least older ones. Now, these ones work with a series of kind of punched out wafers, so they're a lot cheaper to produce than typical locks, which require pins, and they get kind of pushed outwards by springs in the core, and when you insert the key, it'll pull them all back in, and then the core will be allowed to move. They come in single-sided and dual-sided designs, I think is the term, where the wafers will interface with the key on either one side or both. Those are generally the same as kind of like any sort of pin tumbler to pick. Now, warded locks, I mentioned these first as being like the worst kind, and I feel like I always fail to explain these well. But basically, with these, what will happen is the key will determine which lock it works in instead of vice versa, which would be kind of how every other lock works. So if you just kind of make a key that will work with all the locks, then you can open them all. It's basically, there's one latch in the top of the lock that will actually open it, and then past that, there's like a couple of restricted sections which will interface with cutouts on the key to make sure that keys won't work with other locks. Now, if you just kind of remove all of it and make most of the key like machine down, then it'll fit into all of them and you can open all of them, which is what that kind of set of keys in the top left there is. That'll open like 90% of warded locks, and these ones are very characteristic. You can tell it's a warded lock by that sort of fascia down there in the keyway that it'll spin freely without actually touching the lock. I think these are said to be good in cold weather. That's about all that you can say good about them, other than that maybe that they're cheap. Now, I was mentioning before that pin tumblers kind of have pins and springs and such in them, and I would imagine some of you are already familiar with this, but I'm just going to kind of run through it again. This is how a pin tumbler works. You have the core of the lock pictured in yellow and the body of the lock pictured in gray. They kind of operate independently of each other. They can the core will spin without the body of the lock. However, that motion is like not possible when you have all of the pins in there. They are in these drilled holes between the body of the lock and the core. So when they're all kind of down like that, they're all pushed down by springs. But when you get the key, you can push them all up to a separation between the two pins in a given pin stack. Pin stack refers to just kind of one of those chambers there, and they will shear between the core of the lock and the body of the lock and allow you to open it. I think I might have some kind of fancy animations here. Here you can see this is the principle that all lock picking kind of operates on, tensioning the lock. Now, in order to do that, you kind of start to turn the core with a tool of your choice. Now, that will put pressure on one of the driver pins, which is the one pictured in blue there. It will be sandwiched between the core of the lock and the body of the lock. If it wasn't clear, this is a cutaway like of the face of the lock, kind of an x-ray view, I guess, from the front. And one of those driver pins will bind up, and you can feel for that because it won't move, and all of the other ones will. From there, you can kind of manipulate it upwards and out of the keyway or out of the core, and it will stay there because the core will slightly rotate and kind of keep it up there. Now, there are some unskilled, or I don't know if I want to call this unskilled necessarily, but more of a random attack that you can go for with that kind of principle, where you would just kind of stick some sort of wavy tool in there. I mean, essentially is what all these are, and you can get more kind of technical into which ones work better. My personal choice would be that second one pictured in black there, triple peak rake. Those are pretty good. Now, you can use that and just kind of there's a lot of technique to a lot of this lock picking stuff, and I can only demonstrate so much of it here by talking, which is the point of the interest group. You can come there, kind of experience some of it for yourself, and then maybe do a little bit of practicing at home, and then become really good at this, and then it's really fun. But essentially, in words, you are randomly sticking this in there, kind of moving it up and down, back and forth, and trying to kind of jiggle all those key pins into a position where they would all push the driver pins out of the lock, allow the lock to kind of shear open with those pins and such. Now, single pin picking, this is a lot more methodical. This allows you more finite control. You pick each pin at a time. You can tell what's going on inside the lock. This will take you a lot further than raking attacks. Now, This is a lot of what I focus on in the physical security interest group because there's a decent amount of technique that goes into this with like security pins and other fun features inside of locks that you could try to learn how to defeat. Next, for other kinds of attacks here, this is more of a kinetic attack. This is a bump key. These are all key blanks that have been machined down to the lowest possible bidding on each of the pin like spaces there. So when I say, I think not all of those words are gonna mean something to everyone, and I'd like to kind of explain what that would mean. You have, with a key, there are about like generally 7 possible positions, at least for residential things, that a key could be cut to for a given pin, and those correspond to different lengths of key pins, which allow for, you know, unique locks and stuff like that. So here what's happened is all of these keys have been cut to correspond with a lock that has all of the longest key pins. And what that'll do, one is it's pretty simple to like get that machine. Like you just like give someone a key code for like all of the maximum depths and they'd cut that. So yeah, that can be done on just like a normal key cutting machine. From there, what this can be used to do is all of those little like kind of spikes left behind on the key there can be used as like speed bumps, I guess you could call them. You kind of put this in the lock, pull it out one, so that one of those recesses is outside of the keyway, and you tension it. And this is super finicky. I've tried to do this. There's definitely some art to it. You got to kind of tension it and hit it with a hammer at the same time. And if you can do it just right, what'll happen is it'll like bounce all the key pins and drivers and stuff around inside of the lock, and it'll allow you to open it. I think some of the theory behind it is that it's kind of like a Newton's cradle, if you're familiar with that, the thing with all the balls that you like release one and then it hits all of them and then the other one goes up on the other side. So the key pins may remain in place, but it'll actually bounce the driver pins up and out of the core, and that'll allow you to open the lock. Are you guys bored yet? Here we have Shimming. This is these two attacks are the same in name, but not really the same in what actually happens there. That's a padlock, shackle shimming on the left there. What you can do is, this is an attack on the actual locking mechanism as opposed to the core of the lock. This obviously only works on padlocks because doors don't have shackles. Now, what you can do is kind of stick a thin piece of metal between the spring-loaded pawl there, which is what's actually holding the shackle in place, and push it out, and you can do that on both sides and it'll open the lock. Now, kind of a similar principle, you can stick a really thin piece of metal between the core and the body of the lock in some very limited cases. Most locks have a kind of a flared front of the core, which will not allow this to happen because the metal would have to make like 2 90-degree bends to get around it. But like if you have a very poorly designed lock, or you just like have a core that's out and you have access to the back, you can kind of slide it in that way, and it'll allow you to pick the lock like one pin at a time, but like really simply, because you're just kind of like lining up where it shears between the driver and the key pin with this piece of metal, and then you like stick it between there, and then it can't come down. So in theory, you don't really even need tensioning for that, and then you can just open the lock that way. Bypassing, this is another attack on the kind of mechanism of the lock. the locking mechanism. You can stick a long pointy piece of metal through the core and pull those pawls back out of the shackle and allow you to open the lock. This is not possible on a lot of locks because there will be some sort of shielding between the opening on the rear of the core and the mechanism, but it is an attack to keep in consideration. Now, here's an overlifting attack. This happens when a manufacturer allows too much space in the body of the lock, and you can actually shove the entire pin stack up and out of the core and open the lock that way. This is very model specific. I believe it's possible on Master Lock 140s and 150s. It's very obviously possible on those crappy clear locks we have for just like demonstrating stuff. Like there's just so much space in there. You could just fit everything up and out. It does require a specific tool here. You can see that kind of metal comb thingy down there. I believe they're just called a comb pick, and you can use it to push all the pins up and out like that. I mentioned these earlier, but these are impressioning attacks. On the left, that's like key impressioning. That's a very involved process. It requires like a key blank and a handle, and you just kind of put it in there. You start tensioning it so one of those driver pins binds up, and you kind of rock it back and forth, and from there you can it'll leave like a witness mark from where the one that was binding was pushed up by the key, and it's kind of hard to see, but you could file it down, and the process from there essentially is that you file it down until it stops leaving that mark, and that's how you know that that one's no longer binding up. So you do that for like all 5 or 6 pins in the lock, and then you have a functioning key. It's maybe a bit of an oversimplification, but that's how that works. These ones on the right, those are tubular lock self-impressioning tools. Like I said, very cheap. They can open a lot of tubular locks. They work by having these kind of like feelers that are around the outside that interface with all like 7 of the pins that are in a tubular lock, and they all have kind of like this uniform resistance created by these sort of like rubber band things that are wrapped around them, which makes it like the only variable in the system ends up being the length of the key pins, because the driver pins are all the same and the springs are all the same, and these are all pushed back like evenly. So if you do it right, it will just impression a key, and you'll be able to use that in the lock going forward. We're coming up on the end, don't worry. Now, this is a decoding attack. This is possible with certain padlocks and other kind of combination locks that have these dial style mechanisms. Now, this one pictured here is a Master 175. Those are very vulnerable to certain bypasses and decoding attacks. You can stick a kind of thin piece of metal between the dials and like feel for the actual gates that actuate the mechanism, and from there you can determine how the dials line up and rotate them all backwards one at a time until you get the actual combination from it. They're generally pretty quick to do that, at least if there's not any shielding and the gap is kind of large. Now, lastly, I did want to acknowledge destructive entry. We have a whole week on these. This is what just about any criminal is going to use. Cordless angle grinder or some sort of bolt cutters. That'll remove your lock very quickly and efficiently, and also destructively. So I don't know, keep that in mind, I guess, as you move forward in your endeavors of trying to determine the best approach for a lock that you own because I mentioned ethics before, and you're not allowed to do this on anything you don't own. That's the end of my presentation. Any questions? Anything? What's up?
Can you tell the story about the B-sides challenge that you did?
Oh, yeah. Okay. So this was B-Sides Rochester. What was that our freshman year, right? 2019. In the winter. So there's this organization Tool, but it's spelled with like 3 O's. I don't remember what the acronym actually stands for. That's the one. Yeah, he's got it. So they were running this like promotional thing at B-Sides Rochester 2019 where they had it was a really cool design. The guy had like a key ring on his belt that had 3 keys on it, and you were supposed to take a picture of these keys without him seeing you. That was the first part. And then from that picture, you were supposed to decode the actual like bitting of the lock. Like how I mentioned before, there are different like cuts for the key. There's about like 7 different positions that each key pin can be, and you were supposed to determine that, and then that gives you a number of like which cut is which. And then he had a gauge for actually like making them yourself. Like you could measure like which height each part of the key is. And you had to this was where the kind of promotional part came in, is you had to buy a key blank for like $2, and he had a ton of key blanks, so I think he expected like a lot of people to be doing this. It ended up just being like me and another guy that ended up buying them, which was kind of unfortunate. But regardless, I took a picture of and then once you got the key blank, you're supposed to like file it down, and with that gauge, you determine that it's like a clone of the one that you took a photo of, and then you put it in a lock that key that he has would have originally worked in, and if it works, then he would like give you free stuff. So I took a photo of those keys, and the actual bitting code, which is what you would be decoding for like in Photoshop, was printed on the side of one of the keys. So I knew from there that all I would have to do is like file down the key, and it would work. So did we like leave and go to lunch and then come back and then you were like, oh yeah, it's only, because there were 3 keys, right? And I was like, oh man, it's going to be a real pain to get a picture of all 3 of these keys. And then he said that it was just the one, and then I was like, okay, well I already have the bitting code for 1. And I just like, I filed it down really quick, and I felt kind of bad because there was like another guy there who had very clearly been working on it for like an hour or so, and just like in Photoshop and like filing it down. And I just came in and I did it in like not very long, and it worked. And then he like gave me the free pick set or whatever it was, and it was a fun competition. I passed the idea off to Allison for like potentially doing that at ISTS this year. There was a lot going on, so I don't think that made it into the final production, but it was just a really cool kind of idea for a competition type deal thing. That's the end of my story. Well, if no one else has any questions, I assume there's pizza at some point today.
Yeah, about 15 to 20 minutes we'll do pizza.
All right then.